This episode is sponsored by Brilliant. Every human being who has ever existed has been born on Earth, and only a handful have ever left our planet, and then only briefly. Yet we often talk of a future where most people live and work in space. How do we reach that time? How do we kickstart the real space age? We've spent a lot of time talking about how we might get into space better, cheaper, and safer. We've also spent time talking about some of the things we can do up there. But there's always a bit of a catch-22 about space industry. Once you have it set up, there's tons of things you can do profitably to grow a space economy and civilization, but a lot of them can't be done until you already have one. A lot of conversation about space often seems like the underpants gnomes from South Park. Phase 1, collect underpants. Phase 3, profit. Phase 2, and overcoming that catch-22, is pretty much the big hurdle we have to jump to get ourselves into space in a major way. Now, not every type of development has some single big thing that sparks a fire of growth. Sometimes it is just incremental. Slowly lowering launch costs lead to more interest and more research and development, which lowers launch costs, rinse and repeat. But it would be nice to have some industry or breakthrough that started the avalanche going. We'll be discussing some possibilities today. Now, many that might occur would be something we can't anticipate, and may be unrelated to what a space civilization might actually run on. As an example, there was no way to guess in advance, or even in hindsight, that we'd discover gold in California and it would turn into one of the largest economies in the world, one that has very little to do with gold either. And that's a good parallel for space, because one of the potential Kickstarters we'll look at today will be asteroid mining for precious metals. Another example might be us getting a mysterious signal, one that's clearly artificial in origin, what SETI has been looking for all this time, and we'd obviously have a big rush to build more space-based telescopes, maybe some very large ones protected from noise on the dark side of the moon, and all the related industry and secondary ones around that might serve as the basis for developing more in space. Or such hypothetical aliens might show up in person offering new technology that helps us master space. Or they might be like the alien from Star Trek IV, showing up out of nowhere demanding whales, and suddenly we need to build massive whale guns to launch whales into space, and with them made we can now use them for launching other things. Many others might be unexpected but only in advance, very obvious in hindsight, what we call a black swan. In hindsight, it's very obvious that improvements in electronics would lead to someone thinking we could build unmanned satellites that would be handy for looking at Earth or transmitting data. Seems very obvious now, but it's not something you saw in early sci-fi much, even those featuring spaceships traveling the galaxy, or with robots far smarter than any electronics we put in space now. Indeed, I tend to expect whatever leads to major space industries is going to be very obvious in hindsight, but at the moment, it's not very obvious. We should ask ourselves first, what do we mean by a Kickstarter? In this case, we'd be looking for something so advantageous that we would start doing it in a robust fashion, and everything else could piggyback onto it, either benefiting from all the infrastructure set up to pursue the Kickstarter, or as a secondary byproduct of it. As an example, if I'm some medieval king wanting to build a cobblestone road to benefit trade, and I start a brickyard and hire a lot of bricklayers, when I'm done doing that, there's going to be a lot of bricklayers looking for work, and a lot of brickyards turning out bricks. So you get more homes made of brick, because it's cheaper to make them now, probably more roads, maybe increased supplies for fuel sources to bake those bricks, or other things needing heat, and then you get secondary industries like taverns and inns opening up along the new road, caravans coming through more, maybe hiring guards needing things fixed, offering to carry letters or packages for people in a secure and cheap way, and so on. This is what we're looking for today. I should also note that we do already have a lot of space industry. It's just by and large a somewhat bizarre product for sale and borders on what we call a monopsony, the reverse of a monopoly where only one entity supplies a service. In a monopsony, you've only got one purchaser who drives what tends to get developed and offered. We do have commercial ventures in space, like communication satellites, but by and large, the big buyers are major governments, and frequently the product being sold is national prestige. That's certainly a real product. Plenty of people have made their livelihoods sculpting monuments, engraving plaques, or painting portraits, and between that, security concerns, and general research, both huge industries, they could be considered Kickstarters or at least setting the ground for making the real one easier and sooner. Same, one can argue that a desire for personal prestige and legacy is at least part of what is fueling our first efforts at private space industries like SpaceX, Blue Origins, or Virgin Galactic, but that's nothing new in art and science funding either. We're obviously looking for something that's flat out profitable, but we don't want to ignore the impact of these routes on helping to get things going. What is profitable in space? Launch costs control that in a large part, and those have been dipping down in recent years. I pointed out in one episode that if our telescope saw a big stack of gold on the moon, it would be profitable right now to launch a mission to collect that. There's not many things more valuable than gold, but that's a decent place to begin hunting. It's not enough for it to be more valuable than gold, of course. Kickstarting a space industry has to be something where the cost of doing it in space is adding more value than the cost of launching it there. Gold is not made more valuable by flying it up to space and minting it into coins there, beyond perhaps some limited novelty value. Novelty isn't enough, not to sustain major growth. It needs to be a major industry, existing or new, or a closely coupled niche of industries. For instance, atomic energy is not too popular on Earth, and it's actually very hard to do much R&D and prototyping. We've literally got billions of dollars in funds waiting and ready for that if someone can provide a place they can do it. And while setting up atomic research on the moon seems like an almost ludicrous idea for just testing out a new reactor design, it might be viable just because there is that much need and aversion to terrestrial testing. Coupled to that, while we don't like atomic rockets near Earth, they are great for deep space, so if you can source your fuel and reactors on the moon and use them just for ships or bases out past cislunar space, like asteroid mining, that suddenly becomes a much more profitable endeavor. Setup for something like that could easily run into the hundreds of billions, but if you're shipping back 100 billion in gold and platinum every year, it's a nice investment. And as history has shown us with mining towns, exactly the sort of thing that kickstarts a new economy around that mining that can grow and branch out. See the episodes Asteroid Mining or Colonizing series for more discussion of that. Now, the more of a precious metal there is on the market, the less value it has, but gold production on Earth is a few thousand tons a year. At current value, that's a couple $100 billion of new gold entering every year. Platinum is a modest fraction of that, and there's other metals in play too. As we discuss in asteroid mining, the launch cost per kilogram doesn't really relate to the price to get stuff home. You launch the mining equipment, not the metal, and launching stuff home costs way less fuel, especially if you can make it on-site or can use atomic rockets. So this is a market where an initial investment of even $1 trillion can get returned fairly quickly, and a market where you could probably expect prices not to tank until you were trying to feed hundreds of billions of dollars of product through a year. This used to be my favorite one for kickstarting space, but as I mentioned earlier this year, I tilt more toward power satellites these days. In our episode on that, I noted that if you can profitably beam energy down to Earth for equal or less than modern power costs, you now have an industry that has a multi-trillion-dollar annual revenue. Power satellites are likely to be, by mass, almost entirely very simple reflective surfaces, a thin metal sheet, and that's exactly what you'd be looking for in terms of an early moon industry. Something you can bulk manufacture with very little complexity, saving you launch costs from Earth. It's a good example though of how a technology might only have a short window to be a Kickstarter. If we design a power satellite next year that can be economically produced at scale to rival coal or oil, and then someone comes by 5 years later with a cheap commercial fusion reactor, you've probably just obliterated that industry. On the other hand, if you've got it in place and robust when someone figured out an aneutronic fusion reactor running on helium-3, you can convert all your meal production on the moon to helium-3 refining with relative ease. Similarly, while there's a lot of precious metals in the asteroid belt, Earth has far more than the whole belt combined, just hard to reach. It's ironic that it's harder to get your hands on tons of gold and platinum buried under your backyard, kilometers down, than stuff on one asteroid millions of times further away, but at the moment it is. Someday someone might invent a superior mining process that lets us far more easily detect and reach stockpiles deep in the crust, or even the mantle, and kill a nascent asteroid mining industry off by doing so. Neither power nor raw materials are really safe industries in space, since improved terrestrial versions might supersede them if they are more cost-effective or developed sooner. If space mining or power is developed first, it becomes more difficult to displace them, what with the terrestrial implications and risk. This is Jeff Bezos and Blue Origin's thinking that heavy industry will preferably be located in space. Note that these markets, power and precious metals, both rely heavily on the moon or asteroids too, and they're not really for things used in actual space. Now I mentioned earlier various substances more valuable than gold, gram for gram, and one of those is diamond, as are a lot of crystals. Interesting thing about space is there's no gravity there, and no way to get rid of gravity on Earth, and in general, many crystals grow easier or come out far better when grown in space. Some can only really be grown there. So crystal growth is a good orbital industry, and there is obviously a lot of money in chips and semiconductors which require crystals, and they tend to have a value in terms of mass that makes gold look cheap. Though again, launch costs aren't about the value per mass of the final product, it's about the cost of all the equipment and consumables involved in making them that would need to be in orbit too. A few examples though. You can grow denser and pure diamonds in space, which are great for industrial applications, not just wedding rings, and you can also make graphene in that environment better, and we're just starting to see how useful that material is for tons of applications. Fiber optics can be done better in space too, and needless to say, telecommunications is a big industry. Heck, communication satellites by themselves are already the largest chunk of private sector space investment. You've got alloys that can only be made in space, or made easier and better there too, and while you might not think of a chunk of non-precious metal as super valuable, we have a lot of things like turbine blades that are incredibly expensive in terms of mass. We engage in very sophisticated and expensive metallurgy with those in order to get just a tiny percentage better performance out of them, and both the private and defense purchasers of those generally consider it well worth it. That includes power plant turbine blades too, but a lot is obviously in aerospace, and that would make it another complementary industry. What improves aerospace in general is going to help spaceflight too. So that's another example of a possible Kickstarter, both as a large economic sector and one whose R&D is likely to have positive feedback on launch costs too. So crystals and metallurgy both offer us potential Kickstarters. Speaking of chemistry in general though, I mentioned earlier looking up various lists of things more valuable than gold, and one of the more amusing ones started out with cocaine, heroin, and meth. Needless to say, we're not really looking to bootstrap space industry with narcotics, but pharmaceuticals are also a huge industry, and another example of one where zero-G might be hugely beneficial. It's not only possible but quite likely that many current or future medications can be made better in space, or for future ones, maybe only in space. We often talk about needing to be careful to preserve our rainforests in case it turns out a cure for some disease is stashed away in some obscure plant there. And that's certainly one of the many reasons to want to preserve those ecosystems, but it's quite probable there are whole classes of medicines we can't even research yet because they can only be done right in 0G, and we just don't have a lot of chemistry labs up there. For instance, we have something called protein crystals. Proteins are macromolecules often containing hundreds of thousands of atoms, rather than the relative handful that most chemicals we use or make crystals out of, and it's very hard to work with proteins for that sort of crystallization in gravity. Gravity and convection, which you don't get in space, are rough enough on simple crystal growth as is, and rougher on protein crystals. We already have a number of medical therapies relying on these, such as monoclonal antibodies or mAbs, and others might allow microscopic dialysis, very handy for things like diabetes, so this would be one area that might boost space industry. Again, anything that can only be done in space or done better there. That's a growing list since we haven't done much actual science in space yet, for all that a big chunk of our astronauts' time on the station is spent tending random experiments sent up with them. And that's a thing to remember too. We'd often say we need to find things to do in space besides science, but there are several million scientists on our planet and over $1 trillion spent on R&D every year. That alone makes it an industry by itself, big enough to support quite a large sector of the economy, even ignoring that at a basic level, the product of science is essentially what our whole modern economy is based off of. We don't want to ignore non-industrial applications either. People talk of space tourism, and tourism is another sector of the world economy that exceeds $1 trillion a year. Disneyland alone gets over 1 million visitors a month and has been around for generations. Even my own home county gets tens of thousands of visitors a year, and as much as I love the place, I'm sure it would attract less tourism than space. Launch costs wouldn't need to drop too much more before a lot of folks could afford that trip, and it's certainly something to brag about when you get home, at least until travel to orbit becomes as cheap as travel to a nearby city, something we talk about in our episode on orbital rings. Prestige is a big one, of course. We talk sometimes about corporate sponsorship for space missions, potentially to the NASCAR level, logos painted all over them, but let me toss out a weird example for the moment. The ISS is visible to the naked eye, and not that big. One can make something bigger and brighter in the sky with a nice thin foil. I don't think we'd ever see billboards hanging in orbit, but a company could right now, for a few $1 million, launch a payload of foil to fold out in the shape of their name or logo and twirl around low orbit for a few months till it burned up. I wouldn't be surprised if we banned that after the first company did it, but imagine the kind of PR bump you get from having your logo sail around the sky over the planet for a few months. Think of all the companies that do skywriting or have a banner dragged by a plane or a blimp. Something like that would be a hazard in low orbit if we did it a lot, though you could set them to burn up pretty quick so they didn't leave debris. But one might imagine building a billboard up at geostationary or even a graveyard orbit above, just a big flat panel, and projecting an image onto it. We often talk about making giant shades or mirrors to hover over Earth to block or reflect light, and those make pretty good projector screens when you think about it. We may have to build those someday too, one of those examples of kickstarting space industry out of necessity that we mentioned earlier, say a swarm of solar shades to help cool the planet, and it would be nice if you could mitigate the cost by renting them out as billboards when they are passing through the Earth's shadow. For that matter, you might be able to use large and temporary signs as a way of sweeping an orbital area clear of debris. And we might use short-term sails or mirrors to tweak a short-term problem like a drought or a hurricane. In some cases, where maybe you have to build up to deal with a temporary problem like an asteroid approaching Earth, but now you want to keep and repurpose those assets with the crisis over, you've got a lot of industries that could help it squeak through. For instance, we talked about space farming some while back, mostly to help feed the people up there, but another example of things more valuable than gold are truffles. I wouldn't suggest space truffles as a future industry, but a novelty market for food grown in space could help supplement space farming, which supplements space development in general by cutting down on transport costs. However, you could end up with some unique foods or flavors that could really only be made in space or low gravity. Of course, another upside to space is that it's a good place to do dangerous research, particularly biological, since it's already removed from any risk contamination, and such a facility would burn up if it came down. Again, R&D is a $1 trillion global industry, and more likely to expand than contract in the near future, and there's a lot of things better done in space for our safety and security, or for the company or client security too. Dedicated servers or data storage in space has some advantages over alternatives. We mentioned a while back in seasteading that small nation-states in the ocean might do well as secure data locations, but one in space could do even better. First, it's very hard to sneak up on a space station compared to an island where you can't even see them till they crest the horizon. Second, there is that horizon, whereas a satellite can do a direct line-of-sight laser beam to and from a client. Right now, while it's encrypted, all your data is bouncing over millions of kilometers of cables someone can directly hack into. Third, if it's damaged, stuff is retrievable from an island or boat usually. It's going to sink, but still be intact, and this is not preferable in this context. Your hard drive on a satellite that falls down is not going to be recoverable, not with its individual atoms falling down as dust people inhale after it crashes and burns in our atmosphere. You'd want redundancy, of course, but you need a few satellites to ensure one was overhead with your data at any given time too, though since orbital periods in low orbit are in the 90 to 120 minute region, that's a pretty decent window for things like backups or transmissions that don't need to be real time. As industry develops, things get cheaper, economy of scale kicks in, and people migrate to follow the jobs, creating or enlarging other industries, new towns, and of course people go for tourism too, or potentially to retire. There are some major downsides to zero gravity, and low gravity hasn't been studied much yet, but there are some indicators it would have some benefits for geriatric medicine, so we could see folks retiring to the moon or low-gravity rotating habitats too. Needless to say, I don't see that being the Kickstarter for space industry, even if it is a big economic sector, but again it is good to remember that black swan event scenario. We were trying to look at options we might be able to predict, but often it is unpredictable even if obvious in hindsight. There's nothing surprising in hindsight about any of our tech giants these days. Microsoft, Facebook, Amazon, Google, and YouTube, and so on, all seem obvious now, but not so much prior to their existence. It is very likely to be something like that, though if I had to pick one from those we've seen today, I'd put my money on power satellites or asteroid mining, both coupled to lunar industries for raw materials or fuel. And I do think we're getting very close now. It won't happen tomorrow, and it probably won't be a big fast boom, but I think history is going to put the start of serious space industry inside a decade of now, and might even point to prior to now as the time. As I said, you couldn't predict a lot of the tech giants many years out, but they weren't actually big surprises when they got moving, and while a lot of us might kick ourselves for not buying stock in them early on, quite a lot of people did and retired young to a beach house to sit around tanning and being smug about their foresight. It's good to get into such things early on, and I can't offer any investment advice on who or what, beyond saying that it really helps to know the science and technology involved so that you can be on the leading edge without having to wildly guess where to be investing yourself or picking a future career. Half of what this channel is about is daydreaming about the future, but the other half is encouraging people to learn by showing them all the awesome options that knowledge offers us as a civilization and as individuals. If you want to enhance your own knowledge of the math and science our civilization increasingly operates on, and have fun while you're doing it, go to brilliant.org/IsaacArthur and sign up for free. And with the holiday season here, consider gifting someone a Brilliant membership. We all know there's little more valuable than knowledge, and sparking a lifelong love of learning is the best gift you can get someone. Help your loved ones nurture their curiosity and build problem-solving skills in a fun, bite-sized way with Brilliant's gift subscriptions. So we're moving into the holiday season, and we've got some appropriate episodes for that. With winter approaching and cold weather ahead, we will contemplate how to make our Arctic regions more livable next week. The week after that, we will look at the Santa Claus machine, and some other technologies like cornucopia devices or replicators for making almost anything you want with the snap of a finger, and examine some of the impact that would have on society and how realistic such technology is. For alerts when those and other episodes come out, make sure to subscribe to the channel and hit the notifications bell. And if you enjoyed this episode, hit the like button and share with others. Until next time, thanks for watching and have a great week. Thank you.